Today we discuss on important topics related to finite field. We start from definition of finite field. We write it here. A, a finite field. Okay. A finite field or Galois field. Okay. Is a field with finite number of elements. Okay. Finite number of elements. Now we write some example related to that topics. If F be a finite field, if A be a finite field, okay, then F has prime characteristics. Then F has prime characteristics P. Okay, prime characteristics P and contain a subfield isomorphic to and contains a subfield isomorphic to ZP. Okay. Now we write one important theorem related to that topics. Okay. If F be a finite field, if F be a finite field, okay, of characteristics P, of characteristic P, and n equal to ZP index in F, then F has p to the power n elements. Okay, or if contains p to the power n element, then this one is better. Okay, if contains this element, okay, p to the power n element, then we also write here proof. Okay, proof of this theorem. Since index of ZP in F equal to n, okay, then what happened? If quotient ZP has a basis, okay, of n elements, basis of n elements, okay, basis of n elements, say b1 b2 dot 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 bn, okay, then what happened here? Every element a of F, every element a every element a of F, okay, is a linear combination of, is a linear combination of b1 b2 bn, okay, that is this a equal to a1 b1 a2 b2 dot 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 a and bn. Okay, AI belongs to AI belongs to this ZP. I equal to 1 2 dot 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 in. Okay, not a problem at all. Now ZP has P elements. Now ZP has P elements. Okay. Hence, F has at most P to the power n elements. Hence, F has at most P to the power n elements. Okay. That means ZP have P elements. Then F has at most P to the power n elements. Okay. Now, since B1, B2, Bn is linearly independent, since B1, B2, Bn, okay, is linearly independent over ZP, okay, then A1, B1, A2, B2, dot 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 An, Bn is distinct for every choice of A1, is distinct for every choice of A1, A2, dot 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 An. Okay, thus F has thus F has exactly P to the power n elements. I think all are understood this easily, or that means every explanation is clearly written here, I think. Okay, that means this one are linearly independent over P and this one number in n. Then this one is distinct for every choice of this A1, A2, An. Thus F has exactly P to the power n elements. Okay. Now we going to discuss another theorem related to that topics. Okay, we erase that portion and write one theorem. Okay, we write the statement of this theorem here. Every element of a field F, every element of a field F of characteristics P of characteristics P and of P to the power and of P to the power n elements. Okay, is a root of polynomial, is a root of the polynomial okay, x to the power x to the power P to the power n difference x belongs to ZPX. Okay, that means every element of a field F of characteristics P and of P to the power n elements, okay, is a root of the polynomial x to the power P to the power n difference x belongs to ZPX. Okay, now move on. F is a splitting field of F is a splitting field of x P to the power n difference x over ZP. Okay, we now prove this one. Okay, that means every element of a field F of characteristics P, okay, and of P to the power n elements is a root of the polynomial x to the power P to the power n difference x belongs to ZPX, and moreover f is a splitting field of x to the power P to the power n difference x over ZP. Okay, now we also prove this one. We write proof here. First note that okay, f difference 0 dot is a commutative group okay of order P to the power n difference 1. Okay, that means this one is a commutative group of order P to the power n difference 1. Thus, that means if be a commutative group of order P to the power n, and then this one is a commutative group of order P to the power n difference 1. Okay, then thus for all a belongs to f to the power n, sorry, f difference 0 singleton 0. Okay, then a to the power P to the power n, okay, difference 1 equal to what? Equal to 1. Okay, that means for all a belongs to this f difference singleton O, then a to the power this order equal to identity, and identity with respect to multiplication is 1. Okay, so this one happen. Now this implies a to the power P to the power n, okay, equal to a. Not a problem at all. Now clearly this one happen. O to the power P to the power n equal to 0. Okay, 0 to the power P to the power n equal to 0. Not a doubt. Now since f contains all the roots of what? Roots of x to the power P to the power n difference x. Okay, then if contains all the roots of these, okay, so if contains a splitting field, if contains a splitting field, okay, if contains a splitting field S of what? X to the power P to the power n difference x, okay, over ZP. Understood? Not a problem at all. Now that means this if contains all this root of this, so if contains a splitting field S of this polynomial over ZP. Okay, so what f is exactly the set of all roots of this one. Okay, so f is exactly exactly what the set of all roots of x to the power p to the power n difference x, okay, root of this, hence f equal to this x, okay. Since f contains this one, okay, that means exactly set of all roots of this polynomial, hence f equal to s, okay. That means f difference 0, okay. F contains all this root of this one, and so f is a splitting field s, but f also exactly the set of all roots of this one, okay. Then this one f equal to s also, okay, not a problem at all. That means one root obviously contain, okay, this f, and obviously all roots are contained in f. So f equal to s also, okay, and f become the splitting field. So that means we also complete this proof easily, okay. First we just write this one is a commutative group of order p to the power n difference one, since f is a commutative group of order p to the power n, so not a doubt also. So I think all are understand this one clearly and properly, and obviously if you get this type of video, please subscribe my channel and follow my channel and see this video regularly and click on like options. So today I stop here. Thank you.